Yes, sir.
Okay, fine. So here, that's why here the example I'm having. So manufacturing process or assembly system. So
Yes,
because
sir.
this process will be done by step by step, something like in a detector, then only the go to the next process. So this thing, no need of that accuracy, no need of that monitoring. Once it is detected, it will be go. So that's why you prefer a say PLC. But
Yes.
here it involves the combination of process of raw materials. So we are making a product from a one raw material into a multiple product.
Okay.
So that time it is in a suitable. Okay. So this product has been visible, like in a car factory, and the assembly section will be, we can see the product, but here the product has been always invisible because
Yes.
it will be go through the pipe that walls, so you can't see that visible. Okay, so then this one designed for the regulatory analog loop control. This will be an high speed control. That's the thing.
Yes.
Okay, this is the difference between the small PLC and DCSs. So
Yes.
now, so here this is in our architecture of Honeywell. So here I'm having in a Honeywell DCS. That DCS architecture will be this thing.
Yes, sir.
So here you can see. So here I'm having two lines. So what is the two line? This is my the communication port line. I mean communication lines.
Yes, sir.
So this communication lines will be fitted on a one device. That will be I will discuss later. So using these two lines only, we can communicate in all devices, including our CPU also. So our
Okay.
CPU model will be a C200E. Okay. So in the CPU also we should communicate with the this communication only. So this is a type of Ethernet communication. So in the SCADA station, runtime, historical tools, and then server stations, all those things will be communicate within a two communication ports only. Okay, this is a simple architecture. So now next thing I'm having the block diagram of that Honeywell. So here you can see this is my model pick of that Honeywell DCS where here I'm having. So here this is in a rack type.
Okay. Yes, sir.
So rack type means what will happen? This power supply will be one power supply will be given through this. So we can add it, whatever the modules, how many models we can add it. This rack will be able to support 17 slots.
Okay.
Okay, totally will be support 17 slots. So first thing, I'm having that FTB module. So FTEB. So what is the name of that FTE now? Fault tolerant Ethernet bridge module. Okay, so fault tolerant Ethernet bridge module. So this Ethernet communication only we are using here.
Yes,
Then
sir.
our CPU C200E. This is our CPU model. Then after that digital output and then analog output I'm connected. So here I'm using only a 6 slots. So
Yes.
now in this digital module I'm having that model number of IDD321. So what does that mean? IDD means input digital. D321 is a model. So in a single module we can communicate a 32 channel
Yes,
inputs.
sir.
Okay, 32 channels we can communicate in this digital input module. So it will be work within a 24 voltage DC power supply.
Yes, sir.
So then the digital output module we are having in a ODD321. So that is means output digital D321 is a model. It also supported 32 channel. Then last thing, input analog H16 is a model, 16 channel input. So it having the resolution of 4 to 20 milliamps, 0 to 10 volt, minus 5 to 10 volt. So like that it having. So we can, if you want means we can change. Then analog in output module, that is an OAV0 output analog V081 is a model. So it having 8 channels. We can communicate in 8-digit analog outputs. That's the thing I'm having. Okay. So now, so here you can see one day I'm connected 6 slots. Suppose I want to add in a more modules. So how should I add it? That's the thing I'm deciding here. So here the DCN module. So with the help of DCN, we can communicate. So what is the DCN? Distributed communication network. Okay, distributed communication network. So using this module we can communicate in a single RTO unit. So RTO means remote terminal unit. So
Yes.
what is it? CNI na? So this is a device to transfer the data from a field and field to data field controller. Okay, so this is a device to transfer from a data to the field and then field to the controller. That's the thing of CNI. So this is a distributed communication network. Sorry, distributed control network. So
Yes,
here,
sir.
this is a single RTO unit. So this DCN will be able to support an 8 RTOs.
Okay.
Okay, this single DCN will be able to support a parallelly of 8 RTOs with the Ethernet communication, or else Profibus, Profinet, we can prefer anything. So then, like that, this C200E will be able to support enough 4 DCNs. So like a 1 DCN, 2 DCNs, so 4 DCNs it will be support. So 4 DCNs will be support now. Then each DCNs will be 8. Then how many RTOs we can able to communicate?
4
4,
and 8.
4 DCNs we are using. So
Yes,
each
sir.
DCNs will be supported 8 RTOs. Then how many RTOs we can support?
Maybe 32, sir.
Yes, right. So 32 RTOs we can able to communicate with these things.
Yes, sir.
So the other thing, this is a CNI, there is a control network interface module. Here I'm having the downlink and then uplink driver. So using this driver only, we can transfer the data to the field and then field it to the controller. That is a CNI. Here I'm having.
Okay.
So now the spec of the DCS, one rack will be in a 17 slots. So one C200 will be in a 4 DCN. Then each DCN will be supporting 8 RTOs. So one C200 will be able to support 32 RTOs. So 32 RTOs means I'm having a 17 slots. So totally how many slots will be required for this single, if you're using a full efficiency of the TCS means 514 slots will be used. Okay. Then our input and output signal will be supported. 17,000 signals it will be supported.
Okay.
Either analog or digital, we can use that.
Sir, in
So then,
iOS, na, we are counting both analog and digital. Both we are
yes,
counting, na? Okay.
yes.
Yes.
Then a programming language will be a FBD,
Okay. Yes.
functional block diagram. Okay. This is only one language. In this C200 will be support. So either no language has been available for this thing. Only the FBD.
Okay.
So now, so this is a model of that FBD. So if you want to communicate an input and output means directly we are having the channel blocks. So that blocks we can take it and then give it as channel number. Then we can easily link that. So digital input and digital output. So
Yes.
here you can see that A. Then A here I'm having.
Okay.
So what is it? A? All the blocks will be having a flag A or A. So like that only it having. Okay. So what is that A? Na? This CPU will be in a A series model. Can say as a series model.
Okay.
So that's why all the functions blocks will be having in last A. Okay. That will I will show. So now here is a small example for the converting ladder to an FBD. I think you already familiar with an FBD, right? In ABB PLCs.
Yes, sir.
Yeah. Okay, fine. So here, small example. If push button has been on, the lamp should be on. I'm given a latch. So
Yes.
here I'm having an OR logic, right?
Yes,
So
sir. Or
either
logic.
this thing will be on, lamp will be on, or else this. So this is an OR logic. So that's why I'm taking OR gate here.
Yes.
So what is that flag A? Flag A means, so it is an on-off switch. So if you want to a simulation or else if you want to control a input from output from a HMI, that time we can prefer a flag A switch.
Okay.
Okay. So if you're on that flag A from a HMI or SCADA means my output will be honored. Either digital input. If it will be only used for the digital,
Yes.
that will also. So now that is an analog input channel. So same thing it having, so A channel A, AO channel A.
Yes.
So I will be showing. Okay. So here we are using the software will be 3 softwares we need. I mean, 2 software is enough. So this is our HMI web display builder. So using this software only we can design HMI as well as SCADA also. So now this is my Experion PKS server. So using this software only we can communicate a server. Then a
Okay.
configuration studio. So this configuration studio you can use it for the adding IO modules or else a programming. So all those things done by a configuration studio. Okay.
Yes, sir.
So now I'm going to click my server to connect. So here I'm connected a server with my home network. Okay. So double click this thing. Then initially my server will be in a stopward. Here my server has been stopped. So after that, I'm giving a start connection. Then click it as. So my server has been started now. So once the server has been linked to our home server, after that only we need to open a configuration studio software.
Okay.
Now the server has been running. So after that, minimize that server software. Then click on a configuration studio.
Yes.
So this is a version of 4.0. Okay. So now here see if the server has been connected, then only so PCs will be show you. This is on a PC.
Yes,
So
sir.
this is my PC name, Honeywell 2 PC. Like that, if you're having control station PC or some monitoring station PC, if you're connecting the same server, it will be show.
Yes.
Same server, but a different IP address. Like that station will be in a differ. So here on 192.168.2.11. So like that, it timing now. So only the station will be different.
Yes, sir.
So here 12, 13. So all those things will be connected within a single server. So we can monitor from, we can control here from.
Yes.
Okay. So now I'm going to connect my PC, this server, Honeywell 2 PC. Now click to connect. So after connecting only, my default settings and then applications will be shown there. So here you can see I'm having enterprise model stations. If you want to create a station means we can, and then a
Yes.
printers, control starter is it trends, displays. So the permissions, so and then L files, all those things will be shown here. So here the Honeywell DCS having a one specification. So what is that now? So we need to create a project means we need to create an asset first.
Yes, sir.
Okay. So what is an asset? You have any idea? Normally the asset.
Maybe hardware configuration.
No, no. Normally you can say like
Okay.
an asset.
Asset means
So it is in a one location or else in a one
how maybe any
thing.
place, maybe their location.
Yeah. Like in a one storage. Okay. That asset
Yes,
means one storage. Yeah.
one storage.
Yeah. So so in this annual PCS, we are calling a programming page should be in a control module.
Yes, sir.
Okay. The programming page name will be in a control module. So that control module where it will be fitted na in asset only.
Yes,
So
sir.
if you want to search a good program na, you can use your asset. Then we can search a program easily. Or else you can search a control module. That's the thing. So all the stations, all the station programs will be fitted on a one asset.
Yes, sir.
So using that asset, we can easily modify or else monitor as change. We can do anything. Okay. So
Yes.
now I'm going to create an asset first. So how should I create the asset means here you can see below of Honeywell PC, I'm having enterprise model.
Mm-hmm.
So in this enterprise model, I'm going to build asset. So I'm going to create a one asset for us. So I'm going to build a build asset. So here you can see so much of persons will be created asset. Okay.
Yes, sir.
So but I'm going to create a new asset here. So how should I create now? And then you can see that one asset will be linked within a one file. You can see. So this asset will be linked within a CM. So CM means control module page.
Yes, sir.
The programming pages. So each asset is having on a one page. So that means some person will be doing a program in that asset. That's the thing. So if you want to take this asset means it's also no problem. But we need to create a new asset here. So Honeywell 2 PC, I'm clicker. Here you can see Honeywell 2 PC, add asset. So click add asset and then create a one asset here. So I'm going to create asset as a day one. Okay, no space and then no any symbols is neglected. Okay, only give it as a day one. I'm given. Then click it. Okay. So after creating a day one asset, you can see here all the asset will be in a loaded, but in this asset only showing in a star symbol.
Yes, sir.
So that means the asset will be created successfully, but not stored in our software. I mean, not save it. So how should I save it now? Just click that asset, then a save. So after saving the asset, the star symbol has been gone. So once you save the asset, then go to the configuration explorer from the left side. Click that. So after that, I'm going to create my control program station. So that is my control strategy. So in this
Yes, sir.
strategy only, we are having the SCADA points as well as config process and control strategies. So there only we can add an IO devices, programming, all those things will be in a config process and control strategies. So now I should click that control config process and control strategies. Now it will be open a one more software, that is an Experion PKS software.
Okay.
Okay.
Yes, sir.
Now I'm going to click on a configuration process. Then you can see Experion PKS. So once again, this the person will be done a program. I should delete it, this thing. Here is a hardware interface, hardware module connection. That's all things will be in a simple.
Yes, sir.
Okay, that thing I will be sure. Before that, I should delete this thing now. So now we are going to see in a full of an interface. I mean simulation now. Yeah, simulation steps we are going to see. So here, so the software will be now only the blank things will be shown. So once the Experion software open, we need to open a tree. In the below of the file, we are having an open tree. So after opening the root I'm having, so in this root only we can add an all modules as well as programming pages also in the below of the root only we can add. So
Yes.
what is it unassign na? So unassign is nothing but if you want to save your program someplace. So here is a no option to save other file location like in a computer, my documents, there we can't save it. So only in unassigned or else you can export our program. That's the thing.
Yes.
So now here you can see in the root, below of the root, I'm having project, then monitoring. So two things I'm having. So in the project, we can add an IO devices. All those things will be done within a project only. So once you want to monitor as well as control, now then you can go to the monitoring mode. So here
Yes.
only we can know this device has been running or not. We can check this thing. So here only. So now I'm going to open a library file. So why you need to open a library file means then only we can use that logic functions, all the things will be. See, this my library files. So in this library only we can communicate. In this library, we are also having an IO devices. See, AB drive devices, AB modules. These all
Yes.
things will be in the modules. Then DNet. So these things will be in IO modules. So but we are using only the function blocks here, not a module. So that's the thing I will be shown. So first, I'm going to click on a root. So now we
Yes.
are going to see a simulation procedure. Okay. So this first thing we need to complete a simulation. So after that, we can go to the interface of our DCS. So first, in the root, right click, new. So write your steps in the notes. Know the steps, right? New
New.
controller C200E. That is our module. So this software will be able to support three modules. But if we
Okay.
are using a C200E, so this is also a one type of CPU only. But this will be on depending on application we can prefer. But
Yes.
here we are using a C200E. It is a 16 MB is enough to save a file. So now I'm choosing this thing. So you written the steps right. Right click, new, controller C200E.
Yes, sir.
Okay, fine. So now I'm clicking the C200E. Then you can see in a C200E, I'm having a simulation. It's my main window. Here I'm having simulation window.
Yes.
So in a main window, during the interface time, we can prefer which type of network we'll be using, which model we are using. So which slot number we are using. In interface time, we can choose this all those things. But in a simulation, now we don't want to choose anything. Directly enable our computer IP address.
Yes,
Okay,
sir.
once if you're enabled now, it will be show the IP address of computer and the name of that computer.
Yes, sir.
Okay, so after enabling the simulation module, just click it OK. Then you can see the C200E 587 will be created. So what is it 587? It is nothing but if you're creating an as much, you can delete it and then create it. Now that number will be counting here.
Okay.
Okay. So C200D I'm created. So, but I created, but you can see it will having a down arrow mark. So
Yes.
what is the down arrows will be showing now? In a monitor, you can see it will be not loaded. So once you loaded that to the monitor, now the down arrow will be gone. So I will be tell that. So if you're expanding the C200D, it having an inbuilt software, inbuilt driver. So what is it now? Control execution environment module. Okay, control execution environment C200E function block.
Yes.
So using this below of that this driver only, we can add an IO devices programming pages. So now I'm going to load this module. So how should I load it now? It having a two options. One option will be a right click load. Okay.
Yes.
So after creating a model, we need to load. So or else we are having a directly in a menu bar, we are having load. So where I'm loading, not to controller, only the software I'm going to load. That's the thing of load here. So it having a small warning message. Just click it continue. Then enable the ticks. So what is the ticks now? See, selected as a post load. I mean previous load will be in a neglected. So you are loading new device loading. Now click it OK. So see my CPU will be loaded to the monitor. So once it is loaded now, it will be in a the arrow will be gone. So the monitor having the C200D. Okay. So now I expand that CW. So I'm going to add a control module. So what is the control module? That is my programming page. So right click new. First we taken a control, but here now we're going to take a control module. You can see. So this is our programming page. So you click it, our programming page will be created. So these pages will be having a 5 pages.
Yes. Sir.
So now, so before that, I'm created one asset, right? So that asset I didn't link it any place here. So I need to link. So how should I link it now? So double click our programming page. Then you can see in a parent asset I'm having. So in this parent asset, I'm going to link this thing. So I'm choosing a my asset. So because all asset will be showing. So my asset will be in a day one, right?
Yes.
So I'm choosing in a day one, then click it OK. Then again OK. So after linking our asset, then I save our programming file, then I close it. So once I need to load it again, so right click load. Okay. So whatever the changes we are doing in a project mode, we need to load it again. So that is a compulsory steps. We need to load. Once we create changes in the project mode, we need to load. That's all. So all those
Yes.
things will loaded. So after that, go to the monitoring mode, then expand a one by one. So here you can see the drive module will be showing in a green color means it is in a properly active, but it is in a blue color means it is in an inactivate state. Okay,
Yes.
red color means it is in a fault. So it having 3 colors. So now I'm going to activate my C200D. So how should I activate now? In a CWE, I'm double click the C200D. Then you can see I'm having the base execution period will be 50 milliseconds. So that means the scanning time will be 50 milliseconds. Then a command, CCE command. So that is what is that now? Control execution environment command. So we need to give a cold start. So what is cold start? What is warm start now? So cold start means nothing but it's a refreshing start. But warm start will be a forced start. Okay.
Okay.
So now I'm going to give a cold start. Ideal means stop mode. I'm clicking a cold start, click it yes. So once if I given a cold start, it will be showing in a green color. That means the CPU will be properly activated now. So now I'm going to the project mode again. Then I'm going to open my programming page. So I only enable the digit simulation steps here. So I don't use an IO channels here because it's in a simulation. So instead of IO channel, I'm having a utility. So in this
Yes.
utility, I'm having a flag. Okay. So
Yes.
using this flag only, we can prefer an on off. So here we can just drag it and drop it. So here we can move that block wherever you want. So here is not an option to move on one place. You can use it anywhere here. Okay. So now after that, what I'm going to do, I'm going to take in a logic. So in that logic, I'm having a and an OR gate. I mean, the logic is has been available and some functions has been available there. So I'm taking and then a OR gate for doing a small program here. So now I'm going to assign this my start push button, stop push button. Then this my output of one lamp something. So I'm going to assign. So now how should I connect this to all these things now? Double click that flag. So I'm going to give a command first. So this is my stop push button, stop underscore PB. Then this is my start. I'm given. So now, so this start push button is that I'm having a PVFL. So what is a PVFL? Now preset value flag. Okay.
Yes.
So I just double click this thing, then link it here. So I'm linked. So after that, I'm going to give an OR gate to this thing. Double click and then link. If it is showing in a plus sign means we need to link somewhere. So once you link at the correct position, it will be gone. Okay. So now the stop push button means with having a must be in a NC. So how should we
Yes.
change this a NC means double click that logic gate. Here I'm having the input invert option. Input invert option. So here second pin has been an invert. Then I'm going to change it this my lamp. Then click it OK. So it will be in a round. That means it is in a inverted. So now I'm going to link this thing. Yeah, I link it now. So after once your programming done now, then I save it again, close it. Then again you need to load, right click, load. So you should enable the ticks here. Then only it will be go to the once again the active state. Then click it, load it. So once it is loaded, now go to the monitor mode, then open a programming module here. See, it will be showing in a red color lines. Then if you want to go into on, having a two method to on, once a PBFL or else a PV. So now I'm choosing in a PBFL, double click. Then actual state of block will be in on. So on means it will be showing like it will be on. Then if you on off, it means so it will be off, but it is still it will be on because the latch will be working here. Okay, now once you stop it now, should enable the stop push button. So on that time it will be stopped. Okay, this is the procedure to use in a programming here. So now, so after that, I'm going to inactivate my programming page. So how should I inactivate? How should I delete these things? So we can't directly go to the close here. So first we need to inactivate our CPU. So right click, change state I'm having, or else double click. I need to give an a CC state will be in ideal. So this is an ideal mode, then it is in a blue color. So after that only we can delete our programming module here. Inactivate selected item. So once you inactivated, all these things will be in a blue color. So after that, delete it one by one in a monitor mode. So once you delete it in a monitor mode, then only we can able to delete or something you can do in a project mode. So now I want to save this program. So how should I save it now? Just drag it and drop it below unassigned, you can leave it. So then in unassigned, you need to note only that module number 589. That is our module number. So now we should delete our CPU directly. It also works. Okay. Oh, so okay, man. So you can do that same thing what I did here, that simulation procedure. So after that we can move. So before that, I'm going to send in one more link. You should join that. Okay.
Yes, sir.